Hey, this is Mr. Hanson. I wanted to look at linear programming with you today. This is just an extension of systems of linear inequalities, and this is something that's come up in maybe the last 60 or 70 years. It's fairly new in terms of the math world, and what it does is it helps you to consider all of your constraints. So you build a problem that has some constraints or limitations, and these constraints are modeled by linear inequalities. And then from there you have what you call a profit function or a maximizing function or a minimizing function. And with that profit function or maximizing or minimizing function, you figure out what the best solution is for you. So I think it'll make a lot more sense if we actually run through this. So let's get started. A company makes and sells two different phones. The talk phone takes 2 person-hours to make, and the speak-up phone takes 3 hours to make. The company has 24 employees, each working 8 hours a day. So there's 192 hours in all that the employees work. The company can manufacture at most 72 phones each day. So the first thing we're going to do is we're going to come up with some constraints. And the most basic constraint, as you might remember from linear inequalities, is this idea that we are working in the first quadrant. So I'm going to put x is greater than or equal to 0, and my other constraint, y is greater than or equal to 0. That limits us to the first quadrant. My second constraint is going to be based on hours. We have 192 hours to work with, and it takes 2 hours for the talkie phone, we'll call that x, and the speak up phone is y, so 2 times the number of talk phones plus 3 times the number of speak phones has to be less than or equal to 192 hours, because that's all the hours the company has in a day. And one last constraint, the company can manufacture at most 72 phones a day. So maybe they only have supplies for 72. So that's an hours limitation, and maybe let's just call this supplies here. So, and we say x plus y has to be less than or equal to 72. Okay, so let's go ahead and just kind of graph these constraints. I'm going to count by tens. And I know this is taking a second, sorry about that. Hopefully that'll be enough for us. So let's go ahead and let's just find some x and y intercepts for this first one here. 2x plus 3y is less than or equal to 92. So I'm going to make a little intercept table, treat this like an equation for the moment. And 192 divided by 2 is 96. So when y is 0, x is 96, and 192 divided by 3 is 64. So when x is 0, y is 64. Let's go ahead and plot those points. So 96, 0, we're going to be about right there. And 0, 64, we're going to be about right there. And we'll make a line kind of like that. And for the next one, let's, oh, and by the way, this is less than the hours, so we're going to shade this downward. Just remember we're shading that downward, not upward. Okay, x plus y is less than or equal to 72. Well, this table is going to be fairly easy to make. X is 0, y is 72, or y is 0, x is 72. So I'm going to put 72 right there, and 72 right there, and something like, oh, let's undo that. Let's try a little bit better. Get a little bit better here, I hope. Something like that. Okay, so there we have that point where they intersect there. And let's go ahead and this is less than, so we're shading that down too. So the region that we're really interested in is this quadrilateral right here. And any of the points inside or on that quadrilateral would be a solution to this equation. And I want you to kind of think about this as we go from the center, as we go outward, we're getting, as we go outward towards each of the vertices, we're getting smaller or larger. And so what's happening is they become more of a valuable point the further outward we get from the center, either more valuable or less valuable. 0, 0 right here is going to be, well, that's not going to help us if we make 0 products and sell 0 products. But up here we're getting more valuable, like at 0.64 or 72.0 or well, whatever that is there. So let's just let's list these points. We've got 0.64. We've got 72.0. We've got 0, 0. And then the final one that really comes into question is this one right here. Well, it's an intersection of 2 lines, so we could really say, we could probably do some, a little bit of elimination with this. So I'm going to rewrite it up here in the top hand corner. 2x plus 3y equals 192. And then I'm going to times that second equation by -2, so -2x plus 2y equals, minus 2y, sorry, minus 2y equals -72. And we add them together and we get y equals 192 minus 72, we get 0, and 9 minus 7, I forgot to times that by 2, minus 144, I'm sorry. So 192 minus 144, and we get 12 minus 4 is 8, and 8 minus 4 is 3, and I believe we get 38. Does that look about right for y? I hope so. And if y is 38, let's plug it in to the original problem right there. 72 minus 38. And 6 minus 3, 34. X is 34. It looks like about 34. Maybe we're off just a little bit, but 34, 38 right there. Okay, so that's kind of our last 34, 38. So these 4 points are really they're the sweet spots on the graph. You're going to either get the most bang for your buck or the least bang for your buck with those 4 points. They're the vertices. So if you have a profit function, let's say you charge $175 for the first phone and $205 for the second phone, the Speak Up, can you plug these numbers in and see what you'd get? Well, at 0, 0, you would just get 0. I started with the easy one. Let's go to the next one. Let's go 0.64. So I'm going to go 175 times 0 plus 205 times 64. And I get 13,120. Okay, let's go 72.0. So 175 times 72 plus 205 times 0. And I'm getting 12,600. And finally, the last one, 175 times 34 plus 205 times 38, and I'm getting 13,740. And as you can see, we've kind of narrowed this down to 4 options, and then we want to choose the best one. It looks like that 3438 is going to be the winner right there. So you'd want to make 34 of the talk phones and 38 of the speak up phones. And business people use this all the time. 34 talk phones and 38 speak up phones. So this is called linear programming. Let me just run through the steps with you one last time. We read the problem. We looked at the constraints on the problem. So we wrote down the constraints using inequalities. We came up with 4 of them. We graphed the inequalities on the graph. Then we came up with these vertex points right here. 1, 2, 3, 4 different vertex points that will either give us a maximum or a minimum amount. And then with those points, we used a profit function. So in this case, the company wanted to charge 175 for the talk phones and 205 for the speak up phones. With that kind of a profit, they can plug in these numbers here, these ordered pairs, and see how many of each phone they should make based on their profit function there. Hope this helps out. Hope it was a little interesting to you, and hope you have a nice day. Thanks. This is Mr. Hanson.